get started. Thanks again for joining today's webinar. This is a methodology breakdown on CDM's AMS-II.G, which is energy efficiency measures in thermal applications of non-renewable biomass, and we'll explain what that is as we go through the webinar. So before we begin going into the methodology specifics, let's do a quick overview of who we are. Envision blockchain solution offers expertise in the Web3 space, specifically in building and maintaining applications that help organizations navigate their Web3 journey. We specialize on guiding organizations through three major milestones of use case analysis, proof of concept development, and scaled deployment. And with our expertise as the builders and maintainers of the Guardian, we offer insights and support to ensure that our clients stay ahead of the curve in this fast-moving and dynamic space. So as you may know, the process of designing and collecting the supporting data for carbon claims is heavily manual and prone to errors. This can be due to a variety of factors, including poor data quality, a lack of assurance, potential double counting, greenwashing, and an overall lack of trust. The Guardian is here to address these issues head-on by leveraging a cutting-edge policy workflow engine. The Guardian can mirror the standards and business requirements of regulatory bodies, creating extremely flexible digital methodologies known as DMRD. This approach not only helps organizations ensure compliance with regulatory requirements, but it also enables them to streamline their carbon accounting processes, improve data quality, and reduce the risk of errors and inaccuracies. So you could think of a policy inside of the Guardian as a digital version of a methodology, and by using the policy workflow blocks like Legos, you could design your desired workflow. And you can see an example of that to the right. We'll also be going through that in our demo. So at the heart of this ecosystem are four key technologies that enable us to deliver trusted and transparent solutions for the carbon market. First, we use decentralized identifiers. By using DIDs, we ensure that carbon credits are issued to the correct party and that they cannot be duplicated or manipulated in any way. Second, we use verifiable credentials. DCs are digital documents that provide information related to the subject, the issuing authority, the type of credential, specific attributes of the subject, and evidence related to how the credential was derived. By using DCs, we can ensure that carbon credits are issued only to those who meet the necessary criteria and that the credits themselves are valid and trustworthy. Third, we use verifiable presentations. VPs are a collection of one or more VCs. And finally, we use a public ledger technology and a policy workflow engine. Our PWE uses fully configurable and human-readable logic blocks that are accessible through either a user interface or an application programming interface, an API. This enables us to create highly customizable solutions that are tailored to meet the specific needs of each individual organization. And by leveraging these technologies, we can deliver trusted, transparent, and customizable solutions. So to the right, we can see an example of our trust chain, which is one of the key benefits of the Guardian, making it a crucial component of our fully auditable ecosystem. The trust chain allows us to track who did what from the very beginning of the workflow to the very end. And this is essential for maintaining transparency and trust in the carbon market, as well as streamlining the verification process. By using the trust chain, we can create VC files that contain all the information that was input by different roles throughout the workflow. This information includes project details, issuance of tokens, and verification of those tokens. This VC file is then stored on the hedera public ledger, which allows for complete transparency and verification through the entire process. We have two versions of Guardian. There's the open source version that's available to fork and use immediately. You can find all the information for that on our GitHub. Then we have the Managed Guardian service, which is a comprehensive solution that provides users with resources, tools, and support. With two options to get started, users can choose between a simple user interface for developing policies and running proof of concept quickly, or a fully customizable APIs for more tailored experience. And if you want more information, you could contact us at info@envisionblockchain.com or on our website. In today's webinar, we have a new methodology to break down with you, and this time it's focused on energy efficiency. We'll break things down with a recap of our previous methodology. Following this, we'll go over our policy creation checklist, which was created by our ESG consultants. This comprehensive guide aims to assist individuals and organizations who are interested in developing their own policies for implementation within the Guardian. Next, we'll introduce you to CDM's AMS-II.G, a small-scale methodology for energy efficiency measures in thermal applications of non-renewable biomass. We'll go over what that means in just a second. We also have some information on different methodologies like AMS-II.G. We'll be able to go over some similarities and differences between these methodologies. Finally, we'll wrap up the webinar by demonstrating our Managed Guardian service and showcasing how it could be used to develop policies and mint tokens. So let's move into the recap of our past webinars. Starting in February, we have been hosting monthly webinars as part of our methodology breakdown series. Each webinar focuses on a specific methodology from our open source library, and it's aimed to help our users or anyone interested in the Guardian to understand how these methodologies can be used. So we've done webinars on Vera VM17, Vera's VM42, as well as Vera's methodology for afforestation, reforestation, and revegetation, where we compared it to gold standards afforestation and reforestation methodology. Recently, we've been doing methodologies that are from CDM, so we have AR ACM 0003 and AMS-III.AR. All of these can be found on our YouTube channel. In this slide, we'll discuss the essential steps you can take to create a policy for the Guardian. Creating a well-defined policy is crucial for effectively implementing the Guardian tool into your projects. So let's go through these steps together. Step one is to identify the standard and an appropriate methodology. You want to begin by identifying the relevant standard or methodology that aligns with your project's goals and requirements. This will serve as the foundation for developing your policy. Step two will be to review the standard and methodology documents. So you'll want to make sure that you read through the documentation provided by the standard and the methodology, so you can ensure that there's a comprehensive understanding of their guidelines, criteria, principles, or even their applicability. Step three is to identify roles, processes, and requirements. By identifying the various roles involved, you'll be able to define the responsibilities in the Guardian, then determine the necessary processes and requirements outlined by the standard. Step four is to identify input parameters and equations. Understand the specific input parameters and equations used in the methodology. This will be essential for accurately calculating and reporting the correct values. If you're using a policy in our open source library, then the equations will just need to be filled out using our forms in order for them to be auto-calculated. Creating a new policy is different because all the equations have to be mapped out using a program like Excel spreadsheets, for example, and then the information will have to be implemented using our policy configurator. Step five is to create a workflow and schema. This is when you'll be able to develop a clear workflow and schema that outlines your step-by-step process for using the Guardian within your project. This helps streamline operations and ensure consistent application. And finally, step six is to build the policy for the Guardian. So moving into an introduction and analysis of CDM AMS-II.G. This methodology is associated with energy efficient measures in thermal applications like the complete replacement of existing biomass-fired cook stoves, ovens, or dryers with more efficient appliances, or you could retrofit the existing units to reduce the use of non-renewable biomass for combustion. This methodology references several tools, which include Tool 30, which is used to calculate the fraction of non-renewable biomass, FNRB, which is a parameter used for the final calculation of emission reduction. It also references Tool 33, which includes default values for common parameters, which also includes default value for FNRB. Along with digitizing the methodology itself, we have digitized Tool 30 and Tool 33, and it's used as a module within our policy. This allows us to use those default values in our calculations, and not only can it be used for AMS-II.G, but it could also be used as a module in any other methodology that references Tool 30 or Tool 33. The last item referenced in this methodology is used for sampling and surveys. So we could take a look at the main equation in this methodology. This equation is used to calculate the annual emission reductions, and it's also what we'll be minting against today in our demo. In green, we have the emission reductions. That's what we're looking for. In orange, we have the emission reductions by project devices of the same type in that year. Then in blue, we have the leakage emissions in that year. And keep in mind that all of these are in respect to the year that you're calculating for. So now that we've looked at the main equation that we're minting against, we could take a further look at the parameters that are used to calculate the emission reduction. So we have parameters like fuel savings, number of operational devices, number of operational days, FNRB, which was the fraction of non-renewable biomass, emission factor. For this specific one, it'll be CO2, and the net calorific value. So I wanted to take a look at the differences between AMS-II.G, TPDD Tech, and the gold standard simplified methodology. Here we have the fuel consumption estimation methods. We have the methods to the left, which are thermal energy output, water boiling test, controlled cooking test, kitchen performance test, and finally the kitchen performance test and boiling test. So gold standard simplified methodology only allows for the water boiling test and kitchen performance test, where AMS-II.G allows for all of them except the kitchen performance test and boiling test as a combined one, not them separately. You could have kitchen performance test by itself and the water boiling test by itself. It just can't be combined. And then we have TPDD Tech that only allows for the kitchen performance test and the kitchen performance test mixed with the water boiling test. Currently, the one we have digitized and will demo today includes the thermal energy output, and we'll continue working on adding the water boiling test, controlled cooking test, and kitchen performance test as options for the fuel consumption estimation. That would be used in the fuel savings that we mentioned as parameters that are used to calculate the emission reductions. Then we have carbon pools and sources in the project boundary. So we have carbon pools, carbon dioxide, methane, nitrous oxide. In the gold standard simplified methodology, all of those are included. In AMS-II.G, it's only calculating for carbon dioxide, and in TPDD Tech, it calculates for all of those carbon pools. Then the GHG sources are coming from fuel consumption, fuel production, and fuel transportation. The gold standard simplified methodology will include all of those. AMS-II.G only includes fuel consumption, and TPDD Tech also includes all of those sources in the calculations. So now we're going to take a look at CDM AMS-II.G, the schemas that we have developed. So at the top, we have our required field, the schema type, question, if we want to allow multiple answers, and the answer. This helps us develop these policies within the Guardian. And each one of these breaks is going to be what we consider a schema. So we have our project detail schema, which is going to include all the relevant information about the project or the person conducting this project. As we go down, we have our project emission reduction. And this is going to include all of those parameters that we mentioned to get that final calculation, which will be here. And that's what we're going to be minting against. Now, we also have a table that is used for those calculations. We have tool 33. This is a complete tool 33, so not every section is going to be included in the calculations. We only pick out the part that we need, which is going to be the fraction of non-renewable biomass, which is FNRB. So the workflow is going to be the same as any other CDM policy that we digitize. So starting to the left, we can see the different colors where we have blue as the project proponent, orange as UNFCCC, green is the BBB, and orange or yellow is the designated national authority. So the project proponent is going to prepare and document the project description and submit it to CDM. The designated national authority is going to approve the project description. UNFCCC adds the project to the project pipeline. The designated operational entity, which we'll refer to them as the VVB, assesses and validates the project description, provides a validation report. Then UNFCCC adds the project to the project registry. The project proponent conducts monitoring and sends their monitoring report to the VVB, and the designated operational entity, or the VVB, will assess and validate the monitoring report and certify the project. Then UNFCCC reviews and issues the CERs. Every step that was mentioned here is the step that we're going to take when we go into our demo. So before going into the demo, I want to talk a little bit about what modules are. So modules are like building blocks that contain specific functions or features. They're designed to make it easier to develop policies, workflows, and other system functionalities. By using modules, you can reuse and enhance existing components, making the system more flexible and adaptable for your needs. So today you're going to see that we're using a module within our policy. So here we have our policy that's already been imported, and this is the AMS-II.G policy. You can see that we're in a dry run setting. And if we click on the edit button, we can see our policy workflow engine. Here we have tool 33. The reason why we're using tool 33 today is to input that FNRB value into our calculations. Tool 30 is not being used because it also calculates FNRB. If you would like to use tool 30, then it could be imported as a module and added to your project. Here we have where we have the module being used in order to calculate it in the custom logic block. And it's also being used in the reports. And again, this is, we mentioned before, Lego blocks where you can build your policy. That's why I said you can use tool 30 if you would rather have FNRB be a value that you're calculating instead of using a default value. And now we could select go. So we're going to start off by creating users. We need to create 3 users, so we're going to select this button here 3 times. And now we see we have user 1, 2, and 3. By clicking on user 1, I can now assign a role, which we're going to assign as the project proponent, and select OK. Then we're going to go down to user 2 and select the VVB. Now we have to give the VVB a name and select OK. We see it says waiting for approval. Once we've assigned the last role, then we'll go back to that. So let's go to user 3 and assign it to the designated national authority. So remember it said waiting for approval when we were in the VVB's profile. Now we have to go back to the administrator, which is our standard registry in this case, and select approve. The standard registry could also select view document, where they could see the information that the VVB provided. And now we're going to select approve. So now we're going to go to user 1 and click on new project. We're just going to be using X's for these values. This was all the information that would be in the project detail. Now we have our crediting period. So for this demo, we're just going to select 1 year from now. And then we could go to our monitoring period, and we're going to do the same. And now you would put what your monitoring plan is. For this methodology, you would have to select what region. This was that table that we showed within the schema. And now we could start putting our information. These are just going to be demo values. And we're going to select OK. So now we see it says waiting for approve. So we're going to go to our designated national authority where they have to approve this project. They can view the document and see all the information that was submitted, from the project details to any other schema that was included. They also see all the auto calculations. And then they could select validate. And now we're going to go to the administrator and click on project pipeline. So we see an add button now. This is where they add it to the project pipeline. They also see all the information, including all the auto calculations. And then they can select add. So now we're going to go to virtual user 1, which is our project proponent, and assign a VB. So you're going to see this drop down here. You could select the VB. And now the VB has access to the project information as well. They're going to select projects. Now they can view this document, see the same things that the designated national authority and the standard registry saw. And if everything looks good, they select validate. And now we're going to go to our administrator. And we see another add button. This is the standard registry adding this project to the registry. And now we could go back to the project proponent where they're going to fill out a monitoring report. So by clicking on report, you're going to see all the values that were already input in here. This needs to be adjusted depending on the monitoring plan that you have and the parameters that need to be updated. And then you can include a map. And select OK. And now we can go to our VBB again. They select on monitoring reports. And they can view what was updated on here and verify it. Now that the monitoring report has been verified, the administrator can now select on the monitoring reports tab, where they now have a mint button. So they can, again, view the document and then select mint. Our status is going to go from minting to minted once it's completed. And then we can select on token history. You're going to have your project, your date. We have our trust chain. By clicking on the trust chain, you can see information like the recipient's name, the token amount. We have 2 here, the minted date, verified signature, what policy was being used, what version it's in. And then when we go to the very bottom, you're going to see all the information step by step of what we did here. So we have the account creation, which was done by the standard registry, policy was created by the standard registry. Then the project was created by the project proponent. We can see we have the automatic completion of project tool 33 and the automatic completion of the project field. You can also select on the VC file where you're going to see all of that data. So none of this was here before. That's coming from tool 33. And you also have the auto calculation coming from the information that we input from the project. Then you see the approving of the project validation, monitoring report was created. So every step that we've taken is going to show up here, who did it in the parties, and the VC file for it, all the way till you mint your VCUs. All right, we're going to end it here. Thank you everyone for joining today. Thanks.